In this video, we're going to look at the concept of limiting reactants for chemistry. Now, guys, this is an important aspect of chemistry. After going through this video, I guarantee you that you'll be able to deal with problems involving limiting reactants for chemistry. So ensure you stay to the very end of this video. Okay, so having known that, let's go into the details of the video. Alright, so we're looking at limiting, okay, reactants. Alright, now note that reactions stop when one reactant is used up. Okay, and again is that the amount of product depends on the limiting reactants. Note again that we can calculate the mass of a product formed in a reaction by using the mass of the limiting reactant and the balanced chemical equation. Alright, now let's use this example to illustrate. Let me get a question that will help us to understand this concept very well. Let's get the typical question on this. Okay, guys, now let's look at this typical question. It says, calculate the mass of aluminium oxide formed when 135 grams of aluminium is burned in air. Okay, now remember that we are looking at the concept of limiting reactants. And we said that the amount of product depends on the limiting reactants, and reaction stop when one reactant is used up. Okay, now the first thing you have to do is to write a balanced equation for this reaction. Okay, so to write the balanced equation, the question says once more, so aluminium oxide is formed when aluminium is burned in air. Alright, so the air there means aluminium reacted with oxygen, alright, to produce aluminium oxide. So to balance this equation, we're going to have, we have two atoms of aluminium here. So this tells us that we are going to add, if we add 2 here now, okay, if we add 2 here now, aluminium is not balanced. Let's balance oxygen. Oxygen, we have 3 here at the right, we have 2 atoms at the left. So to balance oxygen, if we put 2 here now, it will be 4. Alright, this place will be 3. What if we put 3 here? If we put 3 here, it will be 6. This place will still be what? 3. So what if we put 2 here? Oxygen will not be balanced. 6. These 2 times this 3, 6. So oxygen is now balanced, but aluminium is now 4. So that means let's add 4 here. Okay, so this tells us that let's remove everything and write the balance equation for this. Alright, so this tells us that the balanced chemical equation will be 4 here. Okay, so we have 3 here and we have 2 here. Okay, burning in air. So this will be the balanced chemical equation of this aluminium burning in air to produce aluminium oxide. Okay, now the next thing we are going to do, let's check again. 4 atoms of aluminium, 4 atoms of aluminium, 6 atoms of oxygen, 6 atoms of oxygen, so it's balanced. Now, the next thing we're going to do will be to calculate the relative formula masses of the elements or compounds in this reaction. So, the relative formula masses. Now, for that of aluminium, the relative atomic mass. Okay, let me give you guys the relative atomic masses of the elements or compounds. Now, remember, I told you that you have to know this because not all questions that they will give you this, or in case you're not given it, you have to be able to decode it. Right, so for aluminium, we have it to be 27. Okay, now for oxygen, we have it to be 16. Which other elements? That's all. So for this aluminium here now note that when you're dealing with limiting reactants, okay, you don't include the mole number, like this mole number where you want to calculate the relative formula mass. So I don't include this mole number here, this mole number here, you don't include it. Alright, when you're dealing with limiting reactants, because normally you would have included it when you're calculating the relative formula mass, but when you are dealing with limiting reactants, don't include the mole number. Alright, so take notes of this. Okay, now let's go ahead and get the relative formula mass of the element. So aluminium here is 27. Okay, now for aluminum oxide, we have it to be 2 times 27 plus 3 times 16. Right, these two here at the base, this small 2 here, okay, will be included. Okay, so when you simplify this, 2 times 27 will give us 54 plus 16 times 3 will give us 48. Alright, so 48 plus 54 give us 102. Okay, this is gram per mole. The unit is gram per mole. Now note that we will include the relative formula mass of oxygen here because oxygen is in excess. So we didn't find the relative formula mass of oxygen because oxygen is burning in excess, is in excess in this reaction. Alright, so when the gas is in excess, you don't need to find the relative formula mass. Okay, so take note of this. Now, the next thing we are going to do, alright, will be to calculate the number of moles of aluminium in 135 gram. So to calculate the number of aluminium in 135 gram will be, remember the formula for number of moles is mass over relative formula mass or molar mass. Alright, so for aluminium it will give us 135 over the relative formula mass of aluminium is 27. Alright, so when you divide 135 by 27, we're going to have it to be 5 moles. Alright, now at this juncture, we check for the mole ratio of aluminium to aluminium oxide. So we have the mole ratio to be 4:2. Okay, now this tells us that 4 moles of aluminium reacted to produce 2 moles of aluminium oxide. Alright, that's how the number of moles are produced. Okay, now if we are asked to find the number of moles of aluminium oxide formed, we would have stopped here by saying that 5 moles of aluminium will react to produce, since this one is half of this one here. Okay, now we would have stopped by saying that 5 moles of aluminium we have to produce, so half of 5 is 2.5 moles, okay, of aluminium oxide. And when we are asked to find the moles of aluminium oxide formed, it would have been 2.5 moles of aluminium oxide, okay, is formed or produced from 5 moles of aluminium that reacted in 135 gram of aluminium. Okay, but since we are asked to calculate the mass of aluminium oxide formed when 135 gram of aluminium is burned in air, alright, so this will be, to calculate the mass now, all you have to do is to times this 2.5 mole. Remember, our formula for calculating mole is mass over relative formula mass or molar mass. Alright, so we now have the mole of aluminium oxide to be 2.5 mole. So all you have to do is to, this 2.5 mole equals this. So the molar mass of aluminium oxide, we got it to be 102. So when you cross multiply, so the mass of aluminium oxide, okay, will be 2.5 mole times 102. Okay, so when you punch in the calculator, you're going to have it to be 255 gram of aluminium oxide. So 255 gram of aluminium oxide will be formed when 135 gram of aluminium is burned in what? Air. So it's as simple as that, guys. Now let me give you guys a practical chemistry question on this, similar to this question, and after it we can call it a class so that you guys will understand this very well. That's why this, I'll look at a practice question on this. Okay guys, now let's look at this question. It says the balance equation for the reaction between chlorine and potassium bromide is, so this is a balance equation. We have 2 atoms of chlorine on the left, 2 atoms of chlorine on the right, 2 atoms of potassium on the left, 2 atoms of potassium on the right, and 2 atoms of bromine on the left and 2 atoms of bromine on the right. So we ask to calculate the mass of potassium chloride. produced when 23.8 grams of potassium bromide reacts in an excess of chlorine. Okay, and we are given the relative atomic mass of the elements to be. So feel free to pause this video and see if you can figure this out using the procedure we used in the previous example. Okay, so pause this video and try this out. Okay, let's do it together. Now, we are going to begin by, let's write the balanced chemical equation out. So we have chlorine gas reacted with potassium bromide. Alright, 2 moles of potassium bromide to give us, okay, 2 moles of potassium chloride plus bromine gas. Alright, now let me write it to it. Okay, let's get the relative formula mass of the elements and compound respectively. Okay, now we're not going to find the relative formula mass for chlorine gas because chlorine gas is in excess. Remember, I told you that when the gas is in excess, you don't find the relative formula mass. So we go to potassium bromide. So for potassium bromide, we're going to give us potassium is 39 plus bromine is 80. Okay, now we not consider this mole value for it, 2 moles of potassium bromide. We not consider the mole value when you are dealing with limiting reactants. Okay, take notes of this. For limiting reactants, when you are adding the relative formula masses, you don't consider the mole value. So this will give us, for that of potassium chloride, it will give us 39 plus 35.5. Okay, so 39 plus 80 will give us 119. Alright, this is gram per mole. This one will give us 39 plus 35.5 will give us 74.5. This is gram per mole. Okay, now let's look at the mole ratio we have in this balanced chemical equation. So we have the mole ratio to be of potassium bromide to be 2:2. That of potassium chloride is to 2 as well. Okay, now this tells us that 2 moles of potassium bromide reacted to form 2 moles of potassium chloride. Alright, now to find, we have to calculate the mass of potassium chloride produced when 23.8 grams of potassium bromide reacts in excess of chlorine. Okay, so find the number of moles of potassium bromide in 23.8 grams of potassium bromide is going to give us, remember that the formula for calculating number of moles is mass over relative formula mass or molar mass. So it's going to give us 23.8 divided by, so the molar mass of potassium bromide is 119. So let me punch this in the calculator. Okay, so this will give us 0.20 mole. Now, since we have the ratio of the potassium bromide to potassium chloride in this balanced chemical equation to be 2:2. Okay, now this shows that 0.2 moles of potassium bromide reacted to form 0.20 moles of potassium chloride. Alright, so 0.20 moles of potassium bromide reacted to form 0.20 moles of potassium chloride. Now, to now get the mass of potassium chloride produced when 23.8 grams of potassium bromide reacted in excess chlorine, it will now be, we now have the number of moles. See this formula here, we are going to apply. So the number of moles now is 0.20. Alright, the molar mass of potassium chloride, we have it to be 74.5. So when you impute it in this formula here, the mass now, the cross multiply, it will now be 0.20 times 74.5. So let me punch this on a calculator. So I have the output to be 14.9 grams. Okay. Alright, so this will be the answer to this question. 14.9 grams of potassium chloride was produced when 23.8 grams of potassium bromide reacted in an excess of chlorine gas. So guys, this basically can deal with the problems involving limiting reactants for chemistry. Hope you learned something from this video. Now, if you are new to the channel, ensure you check the description of this video below. Send it to our Telegram channel. Click on it and join the Telegram channel for instant notification. Also, ensure that you're subscribed to this channel by hitting the subscribe button for more videos like this. Like, share, and comment on this video. Know how you feel from what I learned from this class. If you seem to have many specific questions asked regarding this topic, feel free to leave a question in the comment section below and I will be sure to give you a response. Alright, now click on the end screen above and I will see you in the next video. Thanks for watching.